Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Hello, future engineers, subscribers, viewers, and students. Here is another sample problem videos in algebra, particularly on coordinates and graphs. I hope that through these sample problem videos, your knowledge in algebra, particularly on the topic analytic geometry and in division of a line segment, equations of lines, will be enhanced and increased. So here is the problem. Show that the midpoint of the hypotenuse of a right triangle is equidistant from all three vertices. By the way, allow me to discuss this with less animation so that I can discuss three problems in a short period of time. So this is problem 29 already. So to show that the midpoint of the hypotenuse of a right triangle is equidistant from all three vertices, let's consider in general a right triangle with legs coincident with the x and the y axis as shown in the figure, and we will call the sides as the base as A and the height as B, the altitude as B, so that the coordinates of this vertex, the right angle vertex, would be at the origin 0, 0. This is at A, comma 0, and this point is at 0, comma B. Since this is the midpoint of the hypotenuse and the ends of the hypotenuse have coordinates A, comma 0 and 0, comma B, the coordinates of the midpoint by midpoint formula already derived in the preceding videos is 1/2 of 0 plus A, so that's 1/2 of quantity 0 plus A, comma 1/2 of B plus 0. So it is at A over 2, comma B over 2. And since this is denoted D sub 1, D sub 2, and this is the midpoint, so D sub 1 equals D sub 2. And it is by distance formula and Pythagoras theorem, square root of A over 2, so this is A over 2 minus 0 quantity square plus B over 2 minus B quantity square. A over 2 quantity square is A square over 4, while B over 2 minus B quantity square is negative B over 2 quantity square, which is B square over 4. So that would be square root of A square plus B square all over 4. And square root of 4 is 2. So therefore, distance 1 equals distance 2 equals 1/2 of square root of quantity A square plus B square. Likewise, distance 3, distance of this midpoint of the hypotenuse from the origin, is square root of quantity A over 2 minus 0 square plus quantity B over 2 minus 0 quantity square. So that's also square root of A square plus B square over 4, or 1/2 square root of A square plus B square. So we have shown that distance 1 equals distance 2 equals distance 3. So it is 1/2 square root of A square plus B square. Conclusion, the midpoint of the hypotenuse of a right triangle is equidistant from all three vertices. So that's it for that problem. Problem 30, write an equation not containing radicals which is satisfied by all points P at x, comma y, which are equidistant from quantity negative 2, comma 5 and 3, comma negative 6. Show that this equation is satisfied by the coordinates of the midpoint of the line segment joining the given 2 points. So first, let's focus on the first part. It is, we have to show that, or we have to write an equation satisfying the condition that from the point x comma y, these 2 points have equal distances from this point. So that is, if I call this distance 1 and this one distance 2, then distance 1 equals distance 2. This is the point negative 2 comma 5, and this is the point 3 comma negative 6. So distance 1 equals distance 2, squaring distance 1 square equals distance 2 square, and by distance formula, beginning with the point x comma y, so distance 1 square is quantity x minus negative 2, so that's x plus 2 square plus y minus 5 quantity square, that's distance 1 square. While distance 2 square is quantity x minus 3 quantity square plus y minus negative 6 or y plus 6 quantity square. Expanding, so this is square of the first x square, so that this is algebra already, plus 4x twice of 2 times x plus 2 square, which is 4, plus y square, then 2 times y times negative 5, negative 10y, plus square of negative 5, 25, equals square of x, x square, 2 times the product, 2 times x times negative 3, negative 6x, plus square of negative 3 plus 9, square of y, y square, 2 times y times 6, 12y, then square of 6, 36. So we can cancel out x square, y square, x square, and y square. Simplifying, we have 4x here, then plus 10x, 4x minus negative 6x, so 4x plus 6x is 10x. Then we have negative 10y minus 12y is negative 22y. Then on the right side, we have 9 plus 36 is 45. 45 minus 25 is 20. 20 minus 4 is 16. Since we can simplify this by dividing everything by 2, so we have 5x minus 11y equals 8. So this is the equation that satisfies the conditions above, that the point negative 2, comma 5 and 3, comma negative 6 are equidistant from the point x, comma y. Then we have to show that the midpoint of the line segment joining these 2 points, the coordinates of the midpoint of the line segment joining these 2 points satisfies this equation. So for the midpoint, 1/2 of negative 2 plus 3 is comma 1/2 of quantity 5 plus negative 6. So 1/2 of quantity negative 2 plus 3 is 1/2, and 1/2 of quantity 5 plus negative 6 is negative 1/2. Then substitute into this equation, 5 times 1/2 minus 11 times negative 1/2 equals 5 halves plus 11 halves. 5 plus 11 is 16 over 2, and 16 over 2 equals 8. So that's why in the left side 8, the right side 8. So we conclude that it's true that the midpoint joining the midpoint of the line segments, joining quantity negative 2 comma 5 and 3 comma negative 6 satisfies the equation. And for the last problem, problem 31, given the 2 points a comma negative a quantity negative 3 comma 4 and b 2 comma 5, find the coordinates of a point P on the line through A and B such that P is A twice as far from A as from B, and that is distance of the point P. Distance from A is 2 times distance from B. Then twice as far from B as from A. This means that distance from B is 2 times distance from A. So we plot the points first into this coordinate system. We have A negative 3 comma 4 and B 2 comma 5. So this is the point in general for part A. The distance of this point from A is twice the distance of the point from B. So distance A is 2 times distance B. That's the interpretation of this part A statement. So that means distance A is 2 times distance B. Distance A over distance B is 2. And the distance, the ratio of their distances is also equal to the ratio of their corresponding horizontal projections. And the horizontal projections would be distance from A is right x, x sub b, minus left x, negative 3. So x sub b minus quantity negative 3 is equal to the horizontal projections of this projection of distance b, which is quantity 2 minus x sub b. So that's the x projection. So x sub b minus negative 3 over 2 minus x sub b equals 2. So this is reduced to xp plus 3. After we cross multiply equals 2 times 2, 4. Then 2 times negative xp, negative xp. xp plus 2xp is 3xp. 4 minus 3 is 1. Therefore, x sub b is 1/3. Then for the second part, let's have the y coordinates projection. Y sub b, because we use this formula here. So y sub b minus 4 is 2 times 5 minus y sub b. Y sub b minus 4 equals 5 equals 2 times quantity 5 minus y sub b, or y sub b minus 4 over 5 minus y sub b equals 2. Cross multiply, so y sub b minus 4 equals 2 times 5, 10, then negative 2yp. yp plus 2yp is 3yp, 10 minus negative 4, or 10 plus 4 is 14. So y sub b is 14 over 3. Therefore, the coordinates of point P would be at 1/3, comma, 14 over 3. So for the second part, distance from B is twice that from A. So distance B is 2 times distance A. So distance A over distance B is 1/2 this time. So we use the same projection. X projection of A, distance A is xp minus negative 3. So xp plus 3 over 2 minus xp for distance B. Then it is equal to 1/2. Cross multiply, 2xp plus 6 equals 1 times 2. So 2, 1 minus 1 times negative xp, negative xp. 2xp plus xp, 3xp, 2 minus 6, negative 4. So x sub p is negative 4/3. Likewise, the vertical projection of distance A to that of distance B is 1/2. So distance A, vertical projection, yp minus 4. Then distance B, 5 minus yp equals 1/2. Cross multiply, 2yp minus 8 equals 5 minus yp. 2yp plus yp is 3yp. 5 plus 8, 13. So y sub b is 13 over 3. So therefore, for the second part, part B, the coordinates of B is quantity negative 4/3, comma, 13 over 3. So that's it for this video. I hope that you were able to follow the explanations and the solutions. And I hope that you can also solve problems related to this or similar to this.